Hi, my name is Tony Berard. We're going to do well, I guess I'll introduce myself. I have a bachelor's degree in mathematics. I graduated from Lawrence Technological University back in 2004, 2005 maybe, 2004. No, I was at OU then. So I think it was 2002 I graduated from Lawrence Tech with a bachelor's degree in mathematics. I got a 3.93 GPA. And then while I was I tried to get a master's degree, but I didn't quite make it. But I do have enough master's level credits for a degree. They're just not the right ones, so I never got a degree. So I know a lot about math, is what I'm trying to say. And I took a lot of statistics courses at the graduate level, so yeah. Anyway, what we're going to do is we're going to do a problem from my book, Points, Lines, and Conic Sections. If you look me up on Amazon, Tony Berard, you might have to type in points, lines, and conic sections, because I'm a nobody in the publishing world. But if you type that in, and maybe with my last name Berard, B-E-R-A-R-D, you'll find me. I'll put a picture of it in the video description, so it'll be available. All right, we're going to do one of the problems from my math book, and it's on the screen, but I'm going to write it here. So we want to reflect the point 4, 1 across the line y is equal to negative 2x minus 4. All right. I probably don't need my glasses now. So we're given a point, and we're given a, how are we looking here? Well, that's pretty good. I got room for my arm. All right. I have to constantly look over there because that's where my computer is. It's just the way it worked out. This is my gaming station, actually, for my my board games. I guess I need to angle myself a little more over here. There. All right. So we'll graph this line. And it's minus 4. So let's put that here. And negative 2x will be about there. So if I go up 1 over, or this, let's put our tick marks like so. So up 2 over 1, we'll put it here, and then up 2 over 1, we'll put it here. So this line is about, I'm just doing it freehand as best I can. All right, so this is our line, and it's y is equal to negative 2x minus 4. All right, looking good. Then we want to find this point, 4, 1. So this is the point 4, 1. And so we want to reflect this across this line. Like, if this line was a mirror, how far would this point see itself in the mirror? And it would be right about there. So my drawing is what it is. So let's So it looks like it's about 1, 2, 3, 4, 5, 5 or 6, and maybe 6 down, 5 down. So we'll say negative 5.5 and negative 6. This is a guess, just based on this really crude drawing. So now let's get through the algebra. Feel the heat. It doesn't feel too hot, so we should be okay. All right, what we would like to do is I have a formula here, and it is the distance between a point and a line using the slope form is d is equal to the magnitude of y naught minus mx naught minus b all over m squared plus 1, the square root of it. Some teachers make you memorize math formulas. If I ever had a class, I wouldn't do that. I would just say you can use a formula sheet. I mean, shoot, we got computers and stuff now. It's all there. Why make you memorize it? All right. So the point x naught, y naught is a point that we are given that's not on the line. And the m and b come from the equation on the line. So m is equal to -2 and b is equal to -4. So we have everything we need to use this equation to tell us the distance between this line and this point. And it's going to be at a right angle. So we put a little notch there for a right angle. All right, so our distance is equal to y naught. So this is x naught, y naught for the purposes of this equation. So x naught is 4 and y naught is 1. So 1 minus, and the slope is -2. So -2 times x naught, which is 4, plus, or no, I looked at the wrong spot. So -2 times 4 minus b. B is -4. So I'll just put plus 4. Minus a negative adding. All over m squared plus 1. -2 times -2 is how you square -2, so that's a +4. Plus 1 is 5. So I'll just put the square root of 5. So this is equal to 1 minus a negative is plus. So 1 plus 8 is 9. 9 and 4 is 13. The absolute value of 13 is 13. So this is 13 over the square root of 5. You could rationalize it or not. We're going to be using this as a radius for a circle, so it's easier to just leave it like that. All right, I have to keep checking my positions and stuff of where I am. All right, so the next thing is, okay, so we want to find the equation of this line here. We don't have a point, but we do know that this needs to be perpendicular to this line. So our perpendicular line, L perp, will be y is equal to some m, I'll put m perp, mx plus b. So y is equal to the perpendicular slope of -2 is you flip it over and you take the negative sign of it. So this will be a positive 1/2 times x plus b. I only have one point that's on this line because I don't know what this point is. So 4, 1 is the only point I have. So we'll put that in there. 4 is the x, 1 is the y. So y is 1. It's equal to 1/2 times x is 4 plus b. 2 goes into 4 2 times. Subtract 2, -1. So b is -1. -1. The perpendicular slope is 1/2. So our line that's perpendicular is y is equal to 1/2 x minus 1. All right, so now we got the equation of this line. And so the next thing we'd like to do is to find this intersection point, because that's going to be the center of our circle. So we need a system of equations with lines, and then a system of equations with a line and a circle. So we're getting there. So now that I have both lines, we'll set up a system of equations. So I guess I'll rope this off. So then the next thing we want to do, I bumped the table. I guess we're still looking okay. All right, the next thing we want to do is to set up a system of equations. So the first one will be the given one. Y is equal to -2x minus 4. All right, still looking good. All right, and the other line is y is equal to 1/2 x minus 1. So we need to solve this for x, y, an ordered pair. We know they're not parallel because they would have the same slope. Parallel lines, if you remember from your math classes, don't intersect. So, well, they do intersect, but it's at the point of infinity. So, is that really intersecting? Good luck finding it. You can take some really high-level math classes where they get involved in projective geometry, affine geometry, stuff like that. That's way beyond what we're doing. There's duality theorems, duals. So anyway, if you keep going in math, you'll get there. All right, I'm still centered. So in order to solve this, since they're both equal to y, I'll set them equal to each other. So -2x minus 4 is equal to 1/2 x minus 1. There's a whole bunch of negative going on here, so I'm going to put a bracket around this and multiply the entire thing by -1. So that'll make a 2x plus 4 is equal to -1/2 x plus 1. So look what that did. Changed all the signs. Now I got 3 positive signs and only 1 negative sign. That's a little bit easier on the eyes. All right, so the next thing we'll do is we'll put our x's on one side and the numbers, the constants, on the other side. So we'll add 1/2 x. And then we'll subtract 4. And that will give us 1/2 x. You can only add and subtract like terms, so I need that x there. 2 is 4 halves. So 4 halves plus 1/2 is 5 halves. And that's going to be equal to 1 minus 4, which is -3. And so we can multiply both sides by the reciprocal, 2/5. So the 5s and the 2's cancel. So I'm just left with x. And we get negative 6/5. So this is negative 6/5 is a little bit more than 1. My graph shows that it's a tiny bit less than 1, but that's because I graphed it by hand without even any graphing paper, so it's a little bit off. Since that's a little bit off, that's a little bit off. You know, that's if you use graphing software, obviously you'll get a lot more accurate results. You won't be able to do any better than the algebra, which is why we're plowing through the algebra. This gives us the exact answers. All right, well, we're trying to find the center of our circle here. So this is going to be h for the circle. And then y, you can plug this negative 6/5 into either equation. I guess I'll use the y equal 2x minus 4. Negative 2x minus 4. So negative 2 times our x is negative 6/5. Minus 4. Negative times a negative is a positive, so we get 12/5. Minus 4. I'll put a 1. We need common denominator, so times 5 over 5. So 12 minus 20 is negative 8. So y is equal to negative 8/5. This is going to be k. So now I have hk as negative 6/5, negative 8/5. So that's negative 6/5 comma negative 8/5. And I'm going to label this C for the center of our circle. So now we got the center of the circle. I don't really have enough room here to do the, maybe I do. But in the interest of clarity of the video, we will switch boards. I have 3 boards here. So we are going to use a circle. Okay, so we know the center of the circle and we know the radius. It's going to be 13 over root 5 squared. So now we can set up our equation of a circle. So the regular equation of a circle is x minus h squared plus y minus k squared is equal to r squared. So both h and k are negative, and we subtract them in the formula. So subtracting a negative is adding a positive. So it's x plus h was negative 6/5, so positive 6/5. Y is y. K was negative 8/5, so plus 8/5. And this was 13 over root 5 squared. 13 squared is 169. Root 5 squared is 5. Excuse me. So that's the equation of our circle. I guess I'm okay. There's a red line on my screen. I'm just going to assume it's okay. All right, so this is the equation of our circle. Now what we'd like to do is to find the intersection points between the circle and the line. So this circle and this line. So that line was y is equal to 1/2 x minus 1. Y is equal to 1/2 x minus 1. So that's our system. So let's solve it. So I already have this solved for y, so I can plug that into this y here. So then I'm going to get x plus 6/5 squared plus y, which is 1/2 x minus 1, plus 8/5 squared is equal to 169 over 5. So we need to do some expansion. Well, first, minus 1, that's minus 5/5, so that's going to turn this into plus 3/5. 3/5. So it'll be a 1/2 x minus 3/5 squared. All right, so now we need to expand it out. So it's x squared plus 6/5 x, and 6/5 x is 12/5 x. 6/5 times 6/5 for squaring it is plus 36/5. Expanding this out, we get 1/2 x times 1/2 x is 1/4 x squared. Gotta watch your powers. 3/5 x times 1/2 x plus another 3/5 x times 1/2 x is 2 times 3/5 x, which is 6/5 x. Yes, you're halving it and then doubling it, which gives you that back. So that's a little confusing, but you're undoing. The formula says to take 2 of them, but the coefficient says half of it. They undo each other. So that's why you just magically get this back. So plus 3/5 x plus 3/5 times 3/5 is 9/25. And this is going to be equal to 169 over 5. All right. Well, there's a bunch of fractions. So what is the least common denominator? We've got 4, 5, and 25, and 5. So this gives us a pair of 5s, 5 and 5, and this gives us a pair of 2s. So 4 times 25 is 100. So our LCD is 100. So I'll put a bracket around this whole thing, and we're going to multiply it by 100. So we have to distribute the 100 to every person in here. So this is a coefficient of 1. So 1 times 100 is 100. So we get 100 x squared. 5 goes into 100 20 times. 20 times 12 is 240. So plus 240 x. 5 goes into 100 20 times. 20 times 36 is 720. Oh, 720. It's not over anything. I'm a little leery of that. Let me think about that again. 5 goes into... I didn't square that properly. 36 over 25. My spider senses went off. I didn't, because I've done this on this piece of paper earlier, and I didn't remember any number near that size, so that's what set my spider senses off. All right, which shows you I'm not copying. I'm actually doing this right off the top of my head as we go through it. All right, so 25 goes into 100 4 times. 4 times 36 is 144. Excuse me. So then 4 goes into 100 25 times. 25 times 1 is 25. So plus 25 x squared. 5 goes into 120 times. 20 times 3 is 60. So plus 60 x. 25 goes into 100 4 times. 4 times 9 is 36. So plus 36. And this is going to be equal to 5 goes into 120 times. 20 times 169 is, I guess I need to do that one. So we put in a 0. 2 times 9 is 18. 2 times 6 is 12, 13. 2 times 1 is 2, plus 1 is 3. So it's equal to 3380. All right, we're going to roll with it. Guess I'll take a peek at my notes just to make sure. I need my glasses for that. Okay, so I went 169 times 20 minus 180. And somewhere, oh, I did it here. So I did get 3380 and 180, which gives us 3200. So yep, I just didn't remember that detail. All right, so 3380 is good. All right, so then this is quadratic, so we need everything on one side. So 3380 minus this 180, 144, and 36 is 180. So if I bring that over to this side for ease of subtraction, that's going to be 3200. And then when I bring it back to this side, it'll be minus 3200. So that takes care of the constants. And then we'll do the x terms. So 240x and 60x is 300x. And then we'll do our x squared terms. 100x squared and 25x squared is 125x squared. And this is equal to 0. Well, there's obviously a lot in common here, so we're going to take out 25 from everybody. 20, with the last two being zeros, that means it's a multiple of 100, which means it's a multiple of 25. 125 clearly is a multiple of 25. You'll be left with a 5, and this is a 3, and leaving from 100 is 4, so you're not going to get anything else out. So let's divide everything by 25. So I will divide by 25. Okay, so 125 divided by 25 is 5. 100 divided by 25 is 4. 4 times 3 is 12, so plus 12x. 100 divided by 25 is 4. 4 times 32 is 128. All right, so now we have this quadratic. I will do synthetic division on it because I know one of the roots. How do I know one of the roots? Because that is a point on the circle. So 4 is a root. So we set up a little box and we write our coefficients: 5, 12, negative 128. And we put the root in the box. So we bring down the 5. This is called synthetic division. So 4 times 5 is 20. We add and we get 32. 4 times 32 is 128. We add and we get 0. So this reduces our the power of our equation from a quadratic to a linear. So this leaves us with 5x plus 32 is equal to 0. So now we finally get the x coordinate of our point. I thought it was about negative 5.5. Now we have it. So 5x is equal to negative 32 divided by 5 divided by 5. So x is equal to negative 32 fifths. And y is equal to, we can use, see my finger? Okay. So y is equal to 1/2 x minus 1. And our x is negative 32 fifths. Minus 1. So this will equal, 2 goes into negative 32, negative 16 times. And this is over 5. Minus 1, which is minus 5 fifths. So we get negative 21 fifths. So xy is equal to negative 32 fifths, comma, negative 21 fifths. Five goes into 32 6 times, so this is 6.4. I had guessed it at negative 5.5, so it's wrong. It's not wrong, but it's a imprecise estimate. But who's going to guess 6.4 on a drawing like that? And negative 21 fifths, 5 goes into 24 times with a remainder of 1, so that's negative 4.2. And I guessed negative 6, so, you know, that's the crudeness of the drawing. But it's in the ballpark, so there you have it. And we can do a check. So I'm going to take this point and this line, negative 2x minus 4, and I'm going to put it in this equation. And I should get 13 over root 5. That will check our work. If you ever have a chance to check your work, you should. That's a proper thing to do. So d is equal to y naught minus m times x naught minus b all over the square root of m squared plus 1. Make sure I got that right. Y naught minus mx naught minus b over, okay. And so the point is the one we just got, which is negative 32 fifths, negative 21 fifths. So negative 32 fifths, I guess I should write this down. So this is our point, and the line was negative 2x minus 4. So now we have what we need to plug into this equation. So the y naught is negative 21 fifths minus m, which is negative 2, times x naught, which is negative 21/5, minus b, negative 4, so I'll put plus 4, over the square root of negative 2 squared is negative 2 times negative 2, which is 4, plus 1 is 5. So we got the right denominator, but that came from the same line, so that's no surprise. The real surprise needs to happen right here. So d is equal to negative 21/5. So I got 3 negatives that are being multiplied together, so the overall thing is minus. 2 times 21 is 42. And I got a denominator of 5 because the hidden 1 times 5 is 5 plus 4. I'm going to convert that to fifths. So that's going to be 20/5. What am I supposed to get? 13 over root 5. Oh, I have a fifth here. Well, negative 21 and positive 20 is negative 1/5. And negative 42 minus another one is negative 43/5. Something happened here. I don't know what it was. I have to sheet up my previous notes. I need my glasses. Negative 2. So 21/5 I got negative 17 plus 4. Well, sometimes in math, I'm having a problem with this one fraction here. Negative 42 over 5. Isn't that 12.8? That's negative 4.2. And that's 4 in my previous work. The only issue is this is supposed to be negative 12.8. .4. Caught it. Finally. So this was an exercise in finding an error. So my error was I put the negative 21/5 in the x naught spot. Negative 32/5 was supposed to go there. So I'm going to draw a line through that and write negative 32/5. So this is instructive. So that's going to make this wrong. So if you have ever, I'm going to leave this in the video because if you ever have to error check your work, this is how you do it. So I'm showing you how to find an error also, which shows you I wasn't copying my work. I made a fresh error as I went through this. So d is equal to negative 21/5. So I still have 3 negatives, so I'm going to get negative 64 over 5 plus 4. all over root 5. 4 is 20 over 5. So I get negative 1/5, which gives me negative 65/5. This is equal to negative 13, and when you take its absolute value, you get positive 13. And now it worked out. So it checked. So the check failed because I didn't properly put in the terms. I even gave myself a chance by writing the coordinates of the point, but I selected the wrong coordinate. So, but the check now worked. So I found an error in the check as I was doing it, but it did not invalidate the actual work. The work was correct. So we found the coordinates of this point. So the original task was to reflect this point across this line. We found the point and we checked it. We got the same distance that we got from the original 4-1 distance to this line, which gave us 13 over square root of 5. Everything works. Math is great. Thanks for hanging out with me. Please consider subscribing to the channel. Share it if you like it. Make a comment if you didn't understand anything I did. And have a great day.